How much range does an EV really lose in winter? The honest answer is, it depends. Cold weather can cut EV range, sometimes by a lot, but there is no single number that works for every car, every trip, and every winter day. This is Tech with Receipts. We are here to show what the number means and whether it matters for your trip. Start with a recent US test from AAA in 2026. AAA tested 3 EVs in a lab. The cars drove the same test at about -7 degrees Celsius and about 24 degrees. The cabin was set to about 22 degrees. In the cold test, the calculated range was between 25 and 50% lower. The average was 39% under those test conditions. But that is not a rule for all EVs. It was 3 cars in a US lab. So the short answer is not 39%. The short answer is, it depends on how cold the car starts, what kind of trip you take, and how that car heats its battery and cabin. Winter range comes down to 3 questions. First, how cold is the car when you leave? A car left outside all night may need energy to warm both the cabin and battery. A car warmed while plugged in starts in a different state. Second, what kind of trip are you taking? Short trips can repeat the warm-up. Motorway trips add steady high speed. Third, which car is it? Cars have different batteries, heaters, heat pumps, software, and cabin settings. 2 cars can have similar rated range and still behave differently in winter. Green NCAP has a useful EU cold weather test. They cool the car to about -7 degrees, leave it cold for 14 to 18 hours, and then test it without pre-warming it. That is useful because every car faces the same cold start condition. So it is good for comparing cars. But it is not a crystal ball for your own trip. Even your road, your speed, your parking situation, and your weather can change the result. The warm-up does not become small just because the trip is short. Imagine 3 short errands. The car cools down between them. You may pay the warm-up cost 3 times while traveling only a few kilometers. AAA's newer test also found that cabin and battery heat used a large share of energy in the cold, especially in its city section. City driving is not always less efficient than motorway driving. Lower speed can help. The point is that repeated cold starts can surprise you. This also matters for where you park. If the car is plugged in, some cars can warm the cabin and battery with grid power. If it is not plugged in, warming it can use battery energy. The real question is not apartment or house. It is, can you charge where the car is parked, and what does its manual say? Now look at a long winter drive. In 2026, the German Car Club tested 14 family EVs at 0 degrees Celsius. Every car followed the same Munich to Berlin motorway pattern on lab rollers. The average speed was 111 kilometers per hour. The cars started cold, without battery preheating. The cars traveled between 32 and 50% less than their listed range. Using the study's figures, the average works out to 41% below listed range. But stop there, because this is where numbers go wrong. That is not a 41% loss caused only by cold. It is not a pure temperature number. It is cold plus motorway speed plus cabin heat plus a cold start. And listed range is a lab number for comparing cars, not a promise for one Swedish winter trip. So what can you do? First, warm the car before you leave while it is plugged in, if your car supports it. This can warm the cabin and, on some cars, the battery. Some of that energy can come from the grid. Check the exact manual. Do not assume every car works the same way. Second, use the live range and route tools. For example, Volvo's Swedish EX30 manual says its display uses recent driving and current conditions. Other cars may calculate range differently. Third, a heat pump can help. In many conditions, it uses less energy than basic resistance heating. But it is not magic. The result changes with temperature and system design. A cold battery is also not the same as a worn-out battery. Cold can cause a temporary drop. Permanent battery aging is a different question. Here is the practical rule. For planning, not prediction. A 40% reduction is not what every EV will lose. It is a planning check. Take the rated range, subtract about 40% as a stress test, and ask, does my winter trip still work with useful margin? If yes, winter is less likely to surprise you. If no, plan a charging stop. Then check the car's live route estimate before you leave. For a city driver, the key question may be repeated cold starts. For a cold climate driver, it may be how cold the car starts and what trip it must do. For a long-distance driver, it may be speed, heat, and the first charging stop. For an apartment resident, it may be charging where the car sleeps. For a homeowner, it may be using a plugged-in warm-up before leaving. For a first-time EV buyer, the question is not only, what is the official range? Ask this instead. Does my winter trip still work with margin? Bring the claim. We'll check the receipt.